Good evening. My name is Tommy Lashley, and today we'll be talking about the OSI model, beginning with the physical layer. The physical layer defines the electrical and the physical specifications for devices. In particular, it defines the relationship between a device and a physical medium. Some of those devices include hubs, repeaters, network adapters, and host bus adapters. The physical layer tells one device how to transmit the medium and another device how to receive it. The standard, such as RS-232, use the physical wires to control access to the medium. That's the physical layer, or layer 1. Now let's take a look at the next layer, which is the data link layer. The data link layer provides a functional and procedural means to transfer data between network entities and to detect and possibly correct errors that may occur in the physical layer. Originally, this layer was intended for point-to-point and point-to-multi-point media, the characteristics of a wide area media in the telephone system. Local area network architecture, which included broadcast cable, multi-access media, and was developed independently of the ISO. That's layer 2, or the data link layer. The next layer, layer 3, again, which sits on top, and we're working our way up the stack. Layer 3 is the network layer, and it provides a functional and procedural means for transferring variable lengths of data sequences from a source to a destination via one or more networks while maintaining the quality of service requested by the transport layer. The network layer performs network routing functions and might also perform fragmentation and reassembly, and report delivery errors. That's layer 3, or the network layer. Layer 3 protocol is the Internet Protocol, or IP. It manages the net connectionless transfer of data one hop at a time, from end system to ingress router, router to router, and from egress router to destination end. Layer 3. Layer 4 is a transport layer. This layer provides transparent transfer of data between end users, providing reliable data transfer services to the upper layers. The transport layer controls the reliability of a given link through data control, segmentation and desegmentation, and error control. Some protocols state and connection oriented. Layer 4 is the transmission layer. And at this layer you have the transmission control protocol and the user datagram protocols. That's layer 4, the transport layer. Layer 5 is session layer. The session layer controls the dialogue connections between a computer. It establishes, manages, and terminates the connections between the local and the remote application. It provides full duplex, half duplex, and simplex operation, and establishes checkpoints, adjournments, termination, and restart procedures. Session 5. Or layer 5, the presentation layer, or layer 6, establish the context between the application layer and the entities, in which the higher layer entities can use different syntax and semantics as long as the presentation service understands both the mapping between them, the presentation service data units, and then the encapsulated into session protocol data units and move down the stack. That's layer 6, the presentation layer. The last layer that we'll be discussing is the application layer. The application layer in the OSI is closest to the end user, which means that both the OSI application layer and the user interact directly with the software application. This application interacts with software applications that implement and communicating components, such as the application programs, fall outside of the scope of the OSI model. The application layer functions typically inside the identifying communication partners, determining the resources and the availability and synchronizing communication. Today we have talked about the OSI model, or the Open Systems Interconnect model, and the different layers within it. This concludes my briefing. Thank you.